In this lesson, we will look at the concept of definite integral. What is integral of a function? Well, you have done some integration. If I ask you to integrate the function f of x, what does it actually mean? Well, you know that integration is the opposite process of differentiation. But what is the physical meaning of integral of a function f of x with respect to x? Well, the physical meaning of that is, if you draw the graph of f of x, if this is the graph of f of x, the integral of that function is a measure of the area enclosed by the graph of the function with the x-axis. That is the physical meaning of integration or an integral. Now, what is a definite integral? Well, the area enclosed by the graph of a function with the x-axis can stretch from negative infinity to positive infinity, or the entire domain of the function. Well, that is rather difficult for us to compute. And so, we will talk about definite integral. So what do you think definite integral would mean? It is a definite area, say x equal to a, 2x equal to b. That means in a definite integral, we are interested in the area enclosed by the graph of the function in that given definite interval. And we will write it like this then. Integral x equal to a to x equal to b f of x dx. It means this is a measure of the area enclosed by the graph of f of x from x equal to a to x equal to b. And that means we are not interested in other areas, just the area in that interval. All right. Now, how do we measure the area enclosed by the graph of a function with the x-axis? Well, areas come in all kinds of shapes. If a shape is a regular shape, like, say, a rectangle, what is the area of a rectangle? If the width is, say, x, and the length is y, we can say area equal to x times y. But if you have an area something like this, it is not a regular shape where we can measure the area using an appropriate formula. Now, therefore, what we will do is, we will use an approximate method. And in this lesson, we will develop that approximate method and then discuss how that approximate method can be made accurate by the method of calculus. And to do that, I'm going to take a specific function, any example, say square root of x, and we will measure the area enclosed by the graph of that function, say from x equal to 0 to x equal to 4. All right, let's try that. Before we do that, let me ask you a question. Now, here is the graph of a function. Now, I take a point here, and I'm going to call this point x f of x. Is it all right? That is the x value, and this is the y value. This is your x, and this is your f of x. And so, if I say construct something that looks like a rectangle here, this is not really a rectangle. Now, the width of that rectangle I'm going to call delta x, the small value of x. And what is the height of that rectangle? The height of the rectangle is different on the right and the left. So on the right, let's say, now if this point we called x f of x. What can this point be called? That point will be x plus delta x, is that right? So if this is x, then this x value is x plus delta x. So this point will be x plus delta x, f of x plus delta x. Is that right? And the area of this rectangle, well, can approximately be calculated as the width of the rectangle. What is the width of the rectangle? Delta x. And the length of the rectangle, which is f of x plus delta x. Is that right? All right, we're going to use this in our discussion today. Now, does this look like the graph of f of x equal to square root x? Well, more or less. Now, we are going to measure the area enclosed by the graph of f of x equal to square root x from x equal to 0 to x equal to 4. Measure that area. And that area will be a measure of approximately, is that right? Integral 0 to 4 square root of x dx. Now, to make it easy for us to measure the area, because we have no geometrical formula to measure the area, something like this. So what we are going to do is, we are going to divide this area into some rectangles. Well, something that looks like rectangles. Now, I'm going to divide, for convenience sake, into 4 rectangles. Now, look at the 4 rectangles that I'm going to construct. Well, I'm going to draw vertical lines. I can probably use a ruler to do that, is that right? I'm going to draw that line, then that line, then this line, and this line. Now, what it does is it divides the whole area into something that looks like rectangles, but they are not really rectangles. Now, I'm going to use broken lines to complete the rectangles. Now, look at this. This is the first rectangle, and the second rectangle will be something like this. The third rectangle will be something like this. The fourth rectangle will be something like this. All right. Now, if you look here, in order to calculate the area of each of these rectangles, we want the width and the height of the rectangle. The height of the rectangle are different. The height of the rectangle is different on the right and on the left. For example, for the first rectangle, the height is this on the right. On the left, the height is 0. For the second rectangle, the height on the right is this, and on the left it is this. For the third one, on the right it is this, on the left it is this, and so on. That means if you use the right side of the rectangle to calculate the area of the rectangle, you get a bigger value than the actual. But if you use the left side of the rectangle to calculate the area, you get a smaller value. So what we can do is, we can actually use the right side first and calculate the area, and then we use the left sides of the rectangle, and we're going to call them right area and left area. Now, what does the right area mean? Right area means we use the right sides of the rectangles to find the area of each of these rectangles. Now, what does left area mean? Left area means we will use the left sides of the rectangle to calculate that areas. Well, what are the things that we need? We need the width of each rectangle. Now, how do you calculate the width? And the width of the rectangle we are going to call delta x. Now, delta x is, what is our a? If I write integral a to b, our a is 0 and our b is 4. And this interval 0 to 4 is divided into 4 rectangles. That means the width of each rectangle is now 1 unit. Now, in general, I want you to watch this. In general, the width of a rectangle is b minus a, in this case it is 4 minus 0, divided by the number of rectangles. Here we have 4 rectangles. Now, if you divide them into 10 rectangles, it will be, delta x will be 4 divided by 10, and so on. Alright, so first we obtain the width of a rectangle as delta x equal to b minus a over n, and in this case it is 0 minus 4 divided by 4. Well, that will be 4 minus 0. We don't need a negative value here. So that will be 4 minus 0, b minus a, over the number of rectangles is 4, and that will be 1. So delta x equal to 1. Now look at the way I'm going to label each x value. Our first x value is 0. Our second x value will be 0 plus delta x. Is that right? 0 plus 1. Our delta x is 1. And our second x value will be 0 plus 2 delta x. Is that right? Our third x value will be 0 plus 3 delta x, and so on. Okay, so we know now each of the x values. Now, what is, we are going to use the right area first. So to construct the right area, we will be using the right side of each rectangle. Now, the first rectangle, look at that. This is the actual area that we are interested in measuring. But the area of the first rectangle actually includes that area also, which is actually in excess. So there is an error here. Now, the right area of the first rectangle will be this height. Now, what is that height? If this is the x value, the height will be f of 1. Is that right? If the x value is 2, the height will be f of 2. The x value is 3, the height will be f of 3. The x value is 4, the height will be f of 4. Therefore, let's write the areas of each of these. We are doing the right area. Tell me, what is A1 equal to? A1 stands for the area of the first rectangle. The area of the first rectangle is delta x divided by the height. And that will be 1 multiplied by f of 1. Delta x multiplied by f of 1. Now, what is our f of 1? F of x is square root of x. So that will be 1 multiplied by square root of 1. And that's equal to 1 unit. Alright, what is A2 equal to? A2 is the area of this rectangle. And that will be delta x multiplied by the right side of the area is f of 2. So that will be delta x is 1 multiplied by f of 2. Because the x value there is 2, this will be f of 2. And that will be 1 multiplied by, what is f of 2? F of x equal to square root of x. F of 2 equal to square root of 2. And that will be square root 2 units. What is A3 equal to? A3 is this area. And that will be this delta x. You notice that the delta x in each case is the same. The delta x, that is 1 unit, multiplied by the right area is f of 3. So that will be f of 3. And that's equal to 1 multiplied by, what is f of 3? F of x equal to square root of x. F of 3 equal to square root of 3. And that is square root of 3. Alright, what is A4 equal to? A4 is this area. And that will be delta x multiplied by the right side, which is f of 4. So that will be delta x is 1 multiplied by f of 4, and that is 1 multiplied by f of 4 is square root of 4. That will be 2. And so the total right area will be, what is the total right area? The total right area equal to 1 plus square root 2 plus square root 3 plus square root 4, which is 2. Now, we can actually calculate that to say, let's do it to 4 decimal places. Give me a value for that to 4 decimal places. Do you have it as 6.1463? Well, check that once again. All right, let's repeat this now, taking the left side of the rectangle. In other words, we will now calculate the left area. The area will be the width multiplied by the left side of the rectangle. Is that right? Okay, let's do that, and let me keep this value. I would say the right area equal to, we calculated that as 6.1463, and we will now obtain the left area. Okay. All right. What is the area of the first rectangle using the left side of the rectangle to calculate the area? The left side of the first rectangle is 0. So that will be 1, the width is 1 multiplied by f of 0, the x value. Remember, we are using the left side. So the width there, the height there is f of 0, which is 0. How about the second rectangle? When you use the left side there, this is the side or the height of the second rectangle, and that height is f of 1. So that will be the delta x is 1 unit multiplied by f of 1, and that will be 1 multiplied by square root of 1, that is square root of 1. Similarly, I can now write it faster, is that right? The area of the third rectangle will be the width multiplied by the left side of the third rectangle. That is 1 multiplied by f of 2, and that will be square root of 2. The area of the fourth rectangle will be delta x multiplied by, this is the fourth rectangle, if the left height will be f of 3, and that will be square root of 3. And therefore, what is the total area? A1 plus A2 plus A3 plus A4. I'm going to write it as the total area is sum of all the A's, or can I call it sum of AI? I'm going to introduce that in a minute. What does that mean, sum of AI, where I can change from 1 to 4. I can be 1. When I equal to 1, it will be A1. When I equal to 2, it will be A2, and so on. Summation of AI means A1 plus A2 plus A3 plus A4. All right, equal to 0 plus 1 plus square root 2 plus square root 3, and what's that equal to? Did you get it as 3.1463? Well, the right area is 6.1463, and that is much more than the actual area. The left area is 3.1463, and that is much less than the actual area. So, as a compromise, we will take the average of these two. Therefore, we would say this value integral, but at the moment we are not going to use the integration here. We would say the average area therefore equal to, what's the average of 6.143 and 3.143? The average of those two values is 4.6446, and this is an approximate measure of the area enclosed by the graph of square root x with the x-axis from x equal to 0 to x equal to 4. Now, what is the meaning of integration? Integration means to bring all together or add. In fact, it is this process is what is called integration. What we have actually done is divide the area into many parts and calculate each area and add them all together. And that's what's called integration. Now tell me, is this an accurate value for the area enclosed by the graph of this with the x-axis? No, it's an approximate value. How would you make it better? More towards the accurate value? Well, it can be made better by increasing the number of rectangles. Instead of dividing into 4 rectangles, suppose you divide it into 10 rectangles. Then the error can be minimized. If you divide it to 100 rectangles, the error can be minimized even more. And that is what the method of calculus is. Now, let me show you how the calculator can be used in measuring these areas and adding these areas by using the summation of a sequence. All right. Now, how do you write the sum of these areas as a sequence? Now, this is the way we have it. The first rectangle, it is, I'm using the right area. F of 1 multiplied by 1, is that right? Plus F of 2 multiplied by 1 plus F of 3 multiplied by 1 plus F of 4 multiplied by 1. That is the area that we actually calculated. And F of 1 means square root of 1 multiplied by 1 for our function. We will replace the f by our function. F of 1 means square root of 1. So height multiplied by the width plus square root 2 multiplied by 1 plus square root 3 multiplied by 1 plus square root 4 multiplied by 1. Now, in mathematical form, we are going to use the summation notation. We're going to sum this sequence. And for this sequence, we have numbers changing from 1 to 4. So I'm going to call it summation I equal to 1 to 4. In other words, I can take any value from 1 to 4. I is an integer. I can be 0, 1, 2, 3, 4, and well, I equal to 1 to 4. The first value of I is 1, then 2, 3, 4, and so on. So summation I equal to 4 square root of, look at this. This is f of 1, f of 2, f of 3, f of 4. So I'm going to write that square root of I. Is that right? I equal to 1. That will be when I equal to 1, you get square root 1. When I equal to 2, you get square root 2. I equal to 3, you get square root 3. I equal to 4, you get square root 4. So that will be square root I multiplied by 1. That is the height. This is the width of the rectangle. So summation I equal to 1 to 4 square root I times 1 is this sequence. Now, how do you evaluate that on the calculator? I'm going to show it to you on the calculator. First of all, how do we enter this in the calculator? Now, this is the way. I'm going to show you how the various steps that you need to take. Now, it will be entered like this. Sum of what? Sum of a sequence. So, sum sequence, what sequence? Our sequence is square root I. Now, in the calculator, in place of I, we will use n. That's much easier. So, remember, I that we use for constructing the sequence is going to be n in the calculator. So, sum sequence square root of n multiplied by 1, that's our delta x. I'm writing it, multiplying by 1 doesn't make a difference, but you must understand that it is the height multiplied by the width, the delta x. Now, sequence of this square root n multiplied by 1 followed by comma 4n. In other words, you're telling the calculator we are doing the sum for n varying from 1, so comma 1 to 4 in steps of 1. Now look at that sequence again. Sum sequence square root n times 1 comma n comma 1 comma 4 comma 1 parenthesis closed, and if you look here there are two parentheses here, so you probably need to close that parenthesis there, otherwise the calculator will give you an error message. What does it mean? Sum the sequence square root n times 1 4n going from 1 to 4 in steps of 1. That's the meaning of that. Alright, let's now try to enter this in the calculator. When I explain the various keystrokes, watch the motion of the mouse and watch the screen. This is probably better than over here. Okay, now sum sequence is obtained. If you look, press second start brings this in, and move 2 steps to the right to choose math, 2 steps to the right, and what we want is sum is item number 5, so press 5, the sum is written on the calculator. We now need sequence. Again go back, second start, and go to optional, 1 step to the right, and again the 5th item is sequence. So you got some sequence written there. Sequence of what? We need square root of n. So put the square root. Where do we get n? First press alpha, and n is on log. So alpha log will give you that n square root of n, parenthesis closed, comma n, that is alpha log, comma, how does it go? n changing from 1 to 4, 1 comma 4 comma instead of 1, end parenthesis, end parenthesis, and enter, you get 6.14626. That's the value that we had already got. Alright? So try and practice this on your own. Now this is the right area. How can you get the left area? If you notice, for the left area, n value will be 1 unit less because you're going on the left. So if you go back here and change this n to n minus 1, that will give you the left area. And on the calculator, if you press second enter, this will be brought back on the screen. So press second enter, and you have the same quantity brought back, and you can edit it. Now take the cursor up and go all the way and stand at n. Well, I want you to stand, say, one step. Now let's go stand at n and press insert. Where is the insert? Second delete is insert. Now what you need to do is press n minus 1 there, so that will be alpha log n minus 1. There you go. And there is an n there, just delete that. So our original n has now become n minus 1, and press enter, and you get 4.146. That is the left area that we had. So we got the right area and the left area on the calculator. Okay, let's say we want to find the area under the graph of f of x equal to square root of x from x equal to 2 to x equal to 7. In this case, our a equal to 2 and b equal to 7. Now, let's do this by dividing this whole area into 10 rectangles. In other words, you're going to use n equal to 10 rectangles. Now, let's take the first rectangle. I'm going to construct just one rectangle, and then this is the first rectangle. And this is the area of the first rectangle. Now, remember, this is x equal to 2, and therefore this height is f of 2. Now, what is the width of a rectangle? Now, I told you earlier that delta x, the width of a rectangle, is b minus a, or b is 7, a is 2. So delta x is b minus a divided by n. Our b is 7 minus a is 2, and our n is 10. So that would be 5 divided by 10. Is that right? 5 divided by 10 is 1/2. So this will be this x value. I'm going to put an arrow here and say that x value will be 2 plus that delta x, which is 1/2. Do you understand that? This x value is 2. The delta x is 1/2. So the next x value is 2 plus 1/2. And so this height will be f of 2 plus 1/2. Now, let me write it above here. This height I'm going to call that way. That height will be f of 2 plus 1/2. Let's construct the next rectangle, the third one. Now, what will be, now, just ignore all these values. This is the second rectangle. That means, let me take off all these x values there to avoid confusion. Now, if this x value is 2, this will be 2 plus 1/2. This x value will be 2 plus 2 times 1/2. That's the second rectangle. Is that right? And therefore, this height will be, try and follow this carefully. That height will be f of 2 plus 2 times 1/2. Now, if I go to the third rectangle, remember the width of each rectangle is 1/2. Can you tell me what will be the right side of the third rectangle be? If I draw the third rectangle, well, that is the third rectangle, the x value will be, what will be the x value? That will be 2 plus 3 times 1/2, isn't it? 2 plus 1/2, 2 plus 2 1/2, 2 plus 3 times 1/2. And what will this height be? That height will be, if I write it over there, it will be f of 2 plus 3 times 1/2. Now, you go from, say, the first rectangle, the second rectangle, the third rectangle. I'm going to ask you, how about the ith rectangle? It should have been better to call it nth. But since we are using I for summation, I'm going to call it ith. Now, I'm going to say this is the ith x value. Let me explain that once again. Now, this is the first x value, that is the starting point, 2. The next x value is 2 plus 1 times 1/2. For the second rectangle, the x value is 2 plus 2 times 1/2. For the third rectangle, the x value is 2 plus 3 times 1/2. Now, this is the ith rectangle. I can be any number from 1 to 10 because we are dividing the area into 10 rectangles. And in that case, this x value will be 2 plus I times 1/2. Is that right? If this I is 5, it will be 2 times 2 plus 5 times 1/2. The I equal to 3 here, that would be 2 plus 3 times 1/2, and so on. So for the ith rectangle, I'm going to write it down over here. Let's write down, for the ith rectangle, the x value will be, what is the x value for the ith rectangle? It will be 2 plus I times 1/2. Again, that I can be 1, 2, 3, 4. For the first rectangle, that x value will be 2 plus 1 times 1/2. For the second rectangle, it is 2 plus 2 times 1/2, and so on. Now, what is the function value? What is the right function value? In other words, what is the height of the rectangle on the right side? Will be the height of the first rectangle on the right side will be f of 2 plus 1/2. In the second case, f of 2 plus 2 times 1/2. For the ith one, what will this height be? It will be f of 2 plus I times 1/2. So the right function value will be 2 plus I times 1/2. I'm going to say that I over 2. Is that right? I times 1/2 is I over 2. Therefore, what is the area of the ith rectangle? What is the area of the ith rectangle? The first rectangle, the second rectangle, the third rectangle, the fourth rectangle, the ith rectangle will be the height. We are doing the right side now. The height is 2 plus I over 2. And the width of each rectangle is 1/2. That's right. So this is the area of the ith rectangle. In order to find the total area from x equal to a, x equal to 2, to x equal to 7, what all we need to do is add up the areas of all these, how many rectangles? 10 rectangles. And how will you do that? The total area is summation of I equal to 1 to 10 of this quantity, 2 plus I over 2 times 1 over 2. That's right. Let's do this on the calculator now. I want you to write this down so that when I do it on the calculator, you know that we are working with this, because when I turn the calculator on, this screen will disappear. I want to apply a small correction in here. The right function value is not 2 plus I over 2, but f of 2 plus I over 2. And the area will be f of 2 plus I over 2 times 1/2. Is that right? Because it depends on the function. This height is f of 2 plus I over 1/2. And our function is square root of x. And so how do you translate this into our function? It will be f of 2 plus I over 2 will be square root of 2 plus n over 2. In place of I, we will use n. And this will be multiplied by 1/2. So f of 2 plus I over 2 becomes square root of 2 plus n over 2. I hope you understand, because our function f of x is square root of x. So f of 2 plus I over 2 is square root of 2 plus n over 2. In place of I, we use n. So take note of this. This is what we enter in the calculator. Well, I hope you know what we are summing now. So go to the calculator. Remember, this is the TI-84 plus calculator. And the keystrokes are exactly the same for TI-83. So you can also use the TI-83. So go to second start, 2 steps to the right, and press 5. That will give you sum. Again, second start, 1 step to the right, and press 5. It gives sum sequence. We now need, the sequence is square root of 2 plus n over 2. So we will say square root alpha log is n over 2, square root n over 2 plus 2. Is that right? Now, we need to change that. That will be square root 2 plus n over 2. So let's do that again. So let's clear it. That will be again second start. That will be sum. Second start, 1 step to the right. Again, sum sequence, square root of square root of 2 plus n over 2, alpha log divided by 2, and close that parenthesis because that's a square root quantity, and then multiplied by 1/2. Use the parenthesis. Parenthesis 1 over 2. Now, once you do that, you have the sequence now, got to say comma n, that is alpha log, comma n, comma 1 to, we got 10 rectangles, so 1 to 10 in steps of 1, and end parenthesis and end parenthesis, and that gives you 10.7656. Now keep track of this value so that we can use it again. Now this is the right area. How can we change this so that it becomes the left area? Remember, each time you take the left area, n is reduced by 1. So if you take this and replace this n by n minus 1, that will be the left area. So let me see if we can do that right here. So what you need to do is press second enter and take your cursor all the way to that n, and we need to change that n to n minus 1. But when you do that, you need to enclose that in a parenthesis. So you say second insert, that is second delete, and start with a parenthesis, alpha log minus 1, n parenthesis, and you can see our old n is there, and just say delete, and that goes. And enter, you get it as 10.1499. So you've got the right area and the left area. You can now see the values are getting a little closer because we took more number of rectangles. So the actual area will be approximately the average of these two. All right. Let's now summarize this process of finding the area under a curve from x equal to a to x equal to b. So the first step is divide the interval from a to b into n rectangles of equal width. And what will be the width of the rectangle? The width of the rectangle will be b minus a over n. So obtain the width of the rectangle. Then the right x value, I hope you understand when I say the right x value. A rectangle has a left x value and a right x value. For the first rectangle, the left x value will be a, and the right x value will be a plus delta x. So the right x value for the ith rectangle will be a plus delta xi. For the first rectangle, the right x value will be a plus 1 delta x. For the second rectangle, the right x value will be a plus 2 delta x, and so on. For the ith rectangle, the right side, the right x value will be a plus I delta x. And what is the right length? In other words, the height of the rectangle. It will be f of a plus I delta x. That is the height. Now, this is the x value on the right side. This is the function value. This is the height. That means the area of the rectangle is the function value, which is the height of the rectangle, times the width of the rectangle. So the right area of the ith rectangle is, which I call dA right, is f of a plus delta xi. I think it has gone out of the screen, but it is this quantity multiplied by delta x. That is obtained from here. So the height of the right height of the ith rectangle, that is this, multiplied by delta x. And find the area Using the right side, we call it A right. The summation I equal to 1 to n f of A plus I delta x, that is the height, times delta x. And the area on the left can be found by replacing I by I minus 1. And that is what we will practice. I think we will practice this using one more example. All right, let's try this one. Find the area enclosed by the graph of y equal to x squared minus x cubed on the interval from x equal to -1 to 0, x equal to a to b, using n equal to 10, dividing the area into 10 rectangles. But what I want you to do is draw a graph of this on your calculator and see how the shape of the graph looks like and figure out what area are we looking for. Well, the graph more or less looked like this. F of x equal to x squared minus x cubed. And let's say this is x equal to -1, and we are looking for the area enclosed by the graph of the function with the x-axis from x equal to -1 to 0. This is the area we're looking for. Well, what is the first step? The first step is we need to find the width of one rectangle. We are going to divide this into 10 equal parts. So what is delta x? Delta x equal to b minus a divided by n. b is 0, a is -1. So 0 minus -1 divided by 10. And that will be 1 over 10. All right. Now, if I take the first rectangle, what is the x value there? Remember that x value will be -1 plus this width, which is -1 plus 1 over 10. All right. The x value on the right side of the second rectangle will be -1 plus 2 times 1 over 10. Is that right? This will be -1 plus 2 times 1 over 10, and so on. Suppose this is the right side, the right x value. I hope you understand when I say the right x value. For the first rectangle, this is the left x value, -1. That is the right x value, -1 plus 1 over 10. What will be the right x value for the ith rectangle? It will be -1 plus, now here it is -1 plus 1 times 110, -1 plus 2 times 110. It will be -1 plus I times 1 over 10, or I over 10. This is the x value of the right side of the ith rectangle. So we say x value of the ith rectangle, and I didn't specify that we are talking about the right side. The x value of the right rectangle will be -1 plus I over 10. Therefore, what is the height? What is the height of the ith rectangle? What is that height? That height will be f of -1 plus I over 10. All right? The height of the ith rectangle will be -1 plus I over 10. Well, f of that, isn't it? This is the x value. The height will be f of -1 plus I over 10. Now remember, our function is this. And that means f of this quantity means you will replace x by this. And so what will that be equal to? The height of the ith rectangle is f of x. X is this value. And that means to get the height, we will replace in here x by this quantity. So that will be -1 plus I over 10 all squared, that's x squared, minus -1 plus I over 10 all to the power of 3. This is our function, f of x equal to x squared minus x cubed. And therefore, the right side height of the ith rectangle will be x squared minus x cubed, where the x value is -1 plus I over 10. I hope you understand this. And to find the area of the ith rectangle, that area, what all we need to do is multiply this quantity by delta x, which is 1/10. So I would say, therefore, delta A of the ith rectangle is -1 plus I over 10 squared minus -1 plus I over 10 to the power of 3. Now, all of this multiplied by 1 over 10. That is the area of the ith rectangle. What all now we need to do is add this for all the 10 rectangles. In other words, we sum this for I equal to 1 to 10, and that will give you the area using the right side. Is that right? So what I'm going to do is, I'm going to take off all this and write this expression there, and make sure that you understand all these processes. All right, come with me one more time. I'm writing delta A right means the area of the ith rectangle using the right side of the rectangle. That will be delta A using the right side will be -1 plus I over 10 minus -1 plus I over 10 to the power of 3. That is x squared minus x cubed. This is your f of x. Now multiply that with the delta x. So height is f of -1 plus I over 10. Replace x by that quantity, you get that. Multiply that with the delta x. Now, this needs to be summed up. So I'm going to say we need to sum it. Summation I equal to 1 to 10 of this. All right, write this down and try and put that in the calculator. Now, the left area can be obtained by replacing this I by I minus 1. Just go one step to the left and then do the addition. That will be the left sum. All right, let's do this now on the calculator. Put this on the calculator, watch the parenthesis. You can see this quantity is in parentheses so that we can square it, and this whole quantity is inside a square bracket so that it is multiplied by 1/10. So after we write sum sequence, start with 2 parentheses. Always make sure that your parentheses are balanced, otherwise the calculator will rebel. Okay, if you are ready, let's go. We need to have sum, that is second, start, right arrow twice, and choose the sum, second start, right arrow once, choose sequence. Sum sequence, we need to have 2 parentheses there, Now, what would you write? Negative 1 plus, always remember, negative 1 is at the bottom one. Don't use the subtraction sign. Negative 1 plus, in place of I we use n, alpha log, negative 1 plus n over 10, n divided by 10, and close that parenthesis, and raise that to the power of 2 squared minus parenthesis negative 1 plus negative 1 plus I over 10 alpha log, that is n over 10 parenthesis closed, raise it to the power 3. Alright, now close the parenthesis, that means we are grouping that whole, and then multiply that by 1 over 10, that is parenthesis 1 divided by 10, parenthesis closed. Now you've got to say about the detail of the summation, that is comma, alpha log n, comma 1, comma 10, that is summation for n from 1 to 10 in step of 1, and parenthesis closed, is that right? And one more? Well, check, otherwise we'll give you an error. There you go. That gives you 0.4875. See whether you get that right. So that will be 0.4875. Now, you can obtain the left area by changing n to n minus 1, and watch me doing that. Bring all this entry back, second enter, and go and stand on the first n and change that to an n minus 1. Remember, when you do that n minus 1, it must be in parentheses. So you are standing on n, say second delete, that is insert. Now say parenthesis n minus 1, parenthesis closed, and just kill that n that is already there. You are done with that. Move to the next n and do the same thing. Alright? Say second insert, parenthesis n minus 1, parenthesis closed, and delete that n there. And I think we are ready, and enter. We get 0.6875. Alright. Now you notice here that we've got the left area here greater than the right area. Can you tell me why? If you look at the diagram, you understand why the right area is greater. So now find the average of these two. That will be approximately the area enclosed by the graph of that function with the x-axis. Well, can you modify this if instead of n equal to 10, suppose we divide the area into 100 equal parts, what difference will there be? Can you work it out? Instead of the number of rectangles being 10, if you want to increase the number of rectangles to 100, that will make our calculation more accurate. What difference will it make? Well, for the first rectangle, the right x value then will be, well, first of all, our delta x in that case will be 0 minus negative 1, which is 1, 1 divided by 100 will be the delta x. The width of each rectangle will be 1 over 100. So this x value will be -1 plus 1 over 100. This x value will be -1 plus 2 over 100. And the x value of the ith rectangle, the right x value will be -1 plus I over 100, isn't it? So -1 plus 1 over 100, -1 plus 2 over 100, -1 plus 3 over 100, -1 plus I over 100. So can you write that summation now? What will be the total area like? The total area will be summation of what quantity? I equal to 1 to 100. Our, well, there you go. -1 plus I over 100. That's our x value squared. Minus -1 plus I over 100 to the power of 3, and multiply that with delta x. What is delta x now? 1 over 100. Alright, can you work this out on the calculator? Alright, let's do the sum using n equal to 100. Let's clear this first and start again. Second start, arrows twice, choose sum. Second start, right arrow once, choose sequence, and you've got to start with 2 parentheses. And what's our function? It will be -1 plus n over 100 alpha log divided by 100, parenthesis closed, square it, minus, parenthesis, -1 plus n alpha log divided by 100, parenthesis closed, to the power of 3, to the power of 3 caret, parenthesis again, to have the whole of the function, multiplied by delta x, parenthesis, what's our delta x? Delta x is 1 divided by 100, and parenthesis closed. Alright, we are now going to sum it, comma, for n going from, comma, 1 to how much? 1 to 100. N changes from 1 to 100 in step 1. Parenthesis closed. And what does that give you? The calculator takes a little while. Gives you 5.733. Now, remember, when you had n equal to 10, we got 0.4875. This time we have 0.573375. Now, let's do the left sum now. Second entry, go to n and change it to n minus 1. So second insert, parenthesis, n minus 1, parenthesis closed, delete that n. That n got left behind here, is that right? So you've got to go back and keep that n there. So always be careful. There you go. And come down to the last n. Where is that one? There. And say insert, parenthesis, n minus 1, parenthesis closed, and kill that n. I hope we got it right. Let's see. Enter, and that gives you 0.59933. 0.5933. You notice how close these have now become. You see? Now, as the number of rectangles is increased, you can see the right area and the left area are coming very close to each other. And if you use n equal to 1000, they will be almost the same. And in calculus, actually, the calculus take the limit when n goes to infinity. You can see how accurate it will be. The calculus is a beautiful way of using approximation to get exact values. But that might sound very odd, but that is true. So when we go to calculus, that sum becomes, how does the sum become? Summation I equal to 1 to infinity of that sum. That's what the calculator does. And that is then called a definite integral. It will be integral -1 to 0 of that function. And let's calculate. Can you take note of these values? Take the average of these and keep it with you. And I'm going to show you how the calculator can be used to find this definite integral. All right? Okay, let's get out of this. Clear? Now, go to the Math menu. Check the Math menu. Where is the Math menu? The Math menu is over here, below alpha. Go to Math menu and go down arrow, until you find this. Well, I've gone again. I need to go and state number 9, finite integral. Enter there. We need to find the finite integral of what? X squared minus x cubed with respect to x. Look at the way it's being entered. Right, comma, and comma, x changing from -1 to 0. That's the way you enter it. So it will be finite integral x squared minus x cubed with respect to x, comma, lower limit, comma, the upper limit, enter. It gives you 0.5833. Now, what is the average of the two areas that we calculated? Does it come very close to this? So you can see, when you increase the number of rectangles, the average sum will actually be the definite integral. And when you increase the number of rectangles to infinite number, there is no distinction between the right area and the left area. Both will be the same. And it will be this value, which is the definite integral of that function from x equal to a to x equal to b. Let's practice one more thing before the tape runs out. Suppose I ask you to find the area enclosed by the graph of this function with the x-axis from x equal to -2 to 2 using n equal to 50. Can you set up this? Well, you know how the graph is going to look like. That's not important for us anyway. It will be something like this. -2 to +2. It is this area that we want. Now, tell me, what is delta x? Well, delta x will be b minus a divided by n. That will be 2 minus -2 divided by 50. That will be, well, 4 divided by 50. That will be 12.5. That's a very difficult number because it's a decimal number. Doesn't matter. That means our delta x, the width of each rectangle is Oh, did I say 12.5? What's wrong there? That should be 1 over 12.5. 1 over 12.5, which is the same as 2 over 25. Let's use it that way. Our delta x is 2 over 25. Therefore, if your delta x is 2 over 25, your right side of the first rectangle will be negative 2 plus 2 over 25. Alright, the x value for the second rectangle on the right will be negative 2 plus 2 times 2 over 25, is that right? And for the ith rectangle, it will be negative 2 plus I times 2 over 25. We'll write it 2I over 25. This is the x value for the ith rectangle. Therefore, the height of the ith rectangle will be f of this x. And so, what will be our sum look like? The delta A, therefore, will be, can you think along with me? What will be delta A equal to? Delta A will be equal to f of x, which will be f of negative 2 plus 2I over 25. Now, this multiplied by the width of one rectangle. What is delta x? Delta x is 2 over 25. And so, when you write it as a summation, it will be some sequence what? Well, it will be negative 2 plus 2I over 25 squared. Alright, I'm going to take that away from there. Minus negative 2 plus 2I over 25 cube, x squared minus x cube, all multiplied by delta x. Delta x is 2 over 25, and you need to sum it. Alright, it will be some sequence of these for n, where n goes from 1 to 50 in step of 1. Now evaluate this and make sure that you learn these kind of skills. Alright? A very important skill of understanding the meaning of a definite integral.